Good morning, good afternoon, and good evening to all of our attendees joining us today for this latest Data Science Central webinar. This is Stephanie Glenn, your host. I am the Editorial Director at Data Science Central. I'm also the creator of statisticshowto.com. I'd like to start our event off today by thanking Rapid Insight for sponsoring today's event. Rapid Insight is a long-time supporter of the Data Science Central community, and we're honored to have them sponsoring our event today. Today's webinar is titled Predictive Modeling's Counterpart, Data Preparation, to be presented by Rapid Insight. Before we begin, I'd like to briefly review the format of today's webinar. Today's event will be 1 hour long. We have two presenters who I'll introduce in just a minute. There will be a 10 to 15 minute Q&A following the presentation. And this event is being recorded and will be available on datasciencecentral.com in a few hours following today's live event. I'd like to encourage our attendees to provide questions throughout the presentation. We will be reviewing and presenting them on your behalf during the Q&A portion of today's event. I'm very pleased to introduce today's speakers, John McMillan and Alex Herber, both with Rapid Insight. John McMillan has over 6 years of experience in data and statistical analysis and data visualization. John is a senior data analyst at Rapid Insight and helps customers in a wide range of industries. In his spare time, he's an avid follower and contributor to Reddit's monthly Data Viz Challenge, and he volunteers for Statisticians Without Borders. Alex Herber has several years of strategic software sales experience and currently manages the sales organization at Rapid Insight. He is passionate about delivering value to organizations with a data-driven mindset and has a relentless curiosity to understand what the market needs. Thanks for being with us today, John and Alex. We're looking forward to your presentation. When plunging into predictive analytics, we often forget to talk about the data preparation necessary for it. In today's Data Science Central webinar, we'll use a movie database as a fun example, and we'll work towards creating a model to predict a movie's overall rating, to see if certain actors, the genre, or even movie length has an impact on its rating. We'll also discuss what to keep in mind in terms of data preparation as we work towards developing a training data set, making sure that the data preparation is repeatable, that all team members understand the process to ensure buy-in, and that additional information can be created from the data available. You'll learn how Rapid Insight's Veera platform makes all of this easy, saving time and resources. Key highlights include democratizing the data, or creating a process that most people would be able to follow regardless of professional background or industry. Ensuring buy-in because it helps you communicate to everyone in the organization about the model and data preparation. Creating a repeatable and schedulable workflow for data preparation. And finally, predicting movie ratings and looking at what type of reviews a movie pitch might get. John and Alex, with that, I'm going to turn it over to you. You can begin as soon as you're ready to go.
Great. Thank you very much, Stephanie. I just want to thank everyone for joining us today on this webinar. This is Alex Herbert speaking. I'm the sales manager here at Rapid Insight. And as you heard, I'll be joined by John McMillan, a senior data analyst, who will be giving you more of the technical components and the main portion of the webinar, as well as the demonstration. So we can jump right in. In terms of what we're going to cover today, I'll give a brief, high-level overview of who Rapid Insight is. We're going to discuss data preparation, And within that, the 80-20 dilemma, which I'll let John kind of go into some of the details. But ultimately, when we look at predictive modeling, you find the data preparation piece is key, and the time spent within that is quite substantial. And we can talk about what this whole dilemma is about. We'll cover a lot of the trends we are seeing in data preparation and predictive modeling, a lot of the challenges faced within that, followed by a product demonstration. And then, as you heard, we will be doing questions and answers at the end, but feel free to ask questions throughout the, or enter questions throughout the portion of the webinar as they come to mind. So with that, I'll jump into who Rapid Insight is. So Rapid Insight, we are a predictive analytics and data preparation software company, empowering professionals of all skill levels to turn raw data into actionable insights. We were founded in 2002 and headquartered in Conway, New Hampshire. We actually just opened up another office in Portland, Maine as well, so we are seeing continued growth, which is a great thing for our company. We're serving hundreds of customers worldwide, ranging from healthcare to higher education to banking, finance, really anywhere where there is a vast amount of data and business cases that involve prepping data and modeling data. As we'll get into the platform here in just a moment, it's a code-free but code-friendly self-service analytics platform, and really enabling users to easily build predictive models, perform advanced data analysis, and share insights within the organization. So let's jump into the Veera platform itself. So the Veera platform is made up of three main components. We have Vera Construct, Veera Predict, and Veera Bridge. Vera Construct is the data preparation tool. It's a visual workflow-based code-free environment that enables anyone from a data scientist to a PhD statistician to turn data into actionable information. We're able to source data from disparate data sources from virtually anywhere and run different cleansing and blending and a myriad of different functions that allow you to end up with an output of data that is cleansed and ready for a predictive modeling application, which is where we go into Veera Predict. It enables users of any skill level to analyze data and build predictive models in a fraction of the time required by other tools. And then here, whether you're looking at anything from retention models to churn or you name it, we can build predictive models within Veera Predict that you can then run your data sets through and have actionable insights to make decisions within your organization on. Veera Bridge is our newest piece of the platform. And this really, when we talk about democratizing data, this is really where you get that. You're able to take the outputs that you're building within Vera Construct or Veera Predict and share that within the organization through a web interface, a cloud-based solution that allows collaboration and decision-making at multiple levels within an organization. And just kind of tying it all together, just a visual representation of a workflow. When you look on the left-hand side, we see the data sources, which could be data that may reside in the cloud. It could be databases, Excel format, different types of data sets that you may have. And you feed those into our Vera Construct product, and that's where you run your data preparation. And from there, you can take your cleansed data and run it through Veera Predict, where you build those predictive models. Veera Predict also enables you to build those automatically, which is a great function. And then from there, we have the ability to take either data sets that come right from Veera Construct or data sets that you've run a predictive model, and again, share those out to those data destinations, whether it be Veera Bridge from Rapid Insight or applications like Tableau, databases, other outputs, and many other applications that you may find out in the marketplace. So with that said, that's an overview of the company, who we are, our Veera platform. I'm now going to turn it over to John, who's going to get into some of the topics we discussed earlier. So I'll turn it over to you, John.
Thank you, Alex, and thanks everyone for joining us today. I'm very excited to be presenting on data preparation. And as Alex mentioned, my name is John McMillan, and I'm a senior analyst here at Rapid Insight. And in that role, I get the unique perspective of working with our customers in many different industries. And so seeing their data analyses, their predictive modeling pursuits across many different verticals. And so one day I may be working with a customer on building a patient readmission model, the next looking at customer churn or employee churn. And then the next looking at student enrollment or student retention. And one thing that is common among all of those industries is that data preparation is often something that we overlook in sort of what we're talking about today, and not necessarily that it's overlooked and that it isn't needed, but the amount of time that we're going to be investing in this is fairly substantial in terms of sort of all of the time when building a predictive model. And so that's what we'll be talking about today, is sort of really what that entails, what the process looks like, and how we can streamline that process within our platform. But starting out, just to get a better idea of sort of who we have in the audience today, I'd like to start with a poll. And so we're interested to know what tools do you currently use to prepare data? So if you don't mind just filling this out here quickly, just to get an understanding of sort of the makeup of the audience here today. Are you using Python or R? Are you strictly looking at SQL queries? Are you working in Excel? Are you using a dedicated ETL tool? Or is there something else that you have within your organization? And if you aren't the one that's actually working on the data preparation, what does your organization use? And I'll just give you a couple more seconds here to enter those in. All right, and I think we'll close this here. And so we have a pretty diverse group of individuals here. So Python and R up there near the top, but SQL and Excel seem to be sort of the top resources here. And so what we'll talk about today is really in any industry, any tools that you're using, what you're probably finding is that data preparation is something that you're spending a lot of time on, and something that isn't necessarily what you want to be spending your time on. And that's exactly what Forbes found when they did a survey of data scientists. They had listed data scientists as the sexiest job a couple years back. And what those new or entering data scientists may not have realized is that 60% of data scientists spend the majority of their time cleaning and organizing data. 19% said it was collecting data sets. So roughly 80% of data scientists say that cleaning and organizing or preparing data and just finding those data sets, accessing that data, is really the majority of the work that they do. And what we'd like to be doing is mining that data for patterns, refining our algorithms, implementing those algorithms, and being able to impact our organization, our customers on that end, and sort of flip this chart here. And sort of to compound things, what Forbes also found was that roughly the same percentage, so that's really the least enjoyable part of the job. So we have this data preparation that's taking up 80% of our workload, and really it's the thing that we enjoy doing the least. And so we need some answers, some solutions to streamline this process, automate it, and make it much easier, much simpler. And so where are we sort of heading, or what are some of the trends that we're seeing within the industry and within the organizations that we work with? In a study by Ventana Research, they found that there's a growing focus on self-service data preparation, with 88% of participants saying that it was important or very important. This means that we're seeing a lot more tools specifically designed for data preparation, tools meant to prepare data for really any output. And so organizations want their data preparation to be easier, more readily available, able to access all of those disparate data, and this has been a growing concern. So in that same study, they also found that 25% of participants had more than 20 data sources that they were working with. 75% said that they were working with 5 or more. And so this is becoming more and more common. We're seeing a lot more cloud-based applications that we're tying into. And so being able not only to have a self-service data preparation tool that automates some of this work here for us, but one that's able to access all of those different data systems is really crucial. Additionally, Gartner released a report just last month in which they identified sort of 4 key elements or sort of the roadmap of data preparation and what organizations are really looking for. And so visual data discovery is something that is growing pretty significantly. Being able to quickly mine the data visually to identify problem areas, key indicators of certain outcomes, and being able to provide that for really all levels of users. So having that be something that the end user can discover on their own, that includes really systems or multiple database systems all together. As we saw, data preparation tools are specifically designated tools for the purpose of data preparation. These tools streamline and automate much of the data preparation process, but additionally, they enhance the communication and governance of the data as well. And then the last two there, automation with augmented analytics and predictive analytics sort of go hand in hand. And as Alan Duncan, the VP analyst of Gartner said, these really enable business users and citizen data scientists to automatically find, visualize, and narrate relevant analytical findings, such as correlations, exceptions, clusters, segments, outliers, and predictions, without having to build models or write their own algorithms. And so we're seeing a lot more of these sort of automated systems, ways to identify key indicators without having to write the code for that, and different ways to implement predictive analytics. We have more data now, generally better quality data, and so we're seeing organizations implement these predictive models in new areas and in new ways. And so next we'll talk about some of the challenges that we face when we're actually building out a data preparation process. But for our last poll here, if you don't mind filling this in quickly, just be, what is the biggest challenge your organization faces when it comes to data preparation? So there's a lot that we have to overcome when we're building out these data preparation processes. Generally, the first thing is data access. We saw that within a lot of these tools or a lot of these surveys, data accessing or data collecting data sets is pretty huge. That's a common issue that we see. Is it just the amount of time that you have? Are there too many requests coming in? You're not able to fulfill all of those and accurately prepare data for your outputs? Is it just the skills or database knowledge within your own organization? Being able to reproduce these analyses or these processes, or is it something else? And we'll leave this here just for a couple more seconds. All right. So skills and data knowledge seem to be the most common issue here, but again, a pretty wide array there. So that's certainly something that we encounter a lot, and that's really where these dedicated data preparation tools are meant to sort of focus on. Being able to create a process intuitively, easily, and being able to communicate that to everyone in the organization and making it accessible and reproducible as well. And that's really some of the main challenges that we're looking to address today as well. So we'll take a look at data access, what that looks like, how we can sort of get around that, assuming that we've been given permissions to the database and that IT is okay with that. We'll also talk about data hygiene. So certainly not necessarily something we can control on the entry side. We can identify areas for improvement as we work through the data, but how we can clean up the data, or historical records maybe, as we go through and prepare data for modeling. And then also making that a reproducible process. So something that we can run on a schedule, we can share with other users, they can improve or work on as well. And then how we can explore the data within the platform to actually generate some database knowledge. And so that's something that certainly comes from working with the data, but how we can quickly sort of go through a data set and learn quite a bit just from sort of viewing the information and identifying those key indicators or problem areas within the database. And then just one thing to sort of keep in mind is changing requirements. Is this something that we may need to modify later on? Are we going to be adding new data elements? Are we going to be maybe predicting an entirely different outcome? Maybe the one that we're looking at is not the one of most importance. So being able to identify that you need an agile tool to implement and modify the processes that you create and the analyses that you're building. And so for that purpose, maybe not something that you're currently doing, but just for fun here today, we're going to be working through an IMDb movie ratings data set. So this is a fairly popular one on Kaggle. You can search for it there and probably find it pretty quickly. And so we're going to be looking at that data set that contains movies, for just over 5,000 movies from the past few years. It incorporates their IMDb score or their review rating to see if we can predict that outcome for sort of a training set and then look at applying that to one that we can model on. And so we'll be looking at that as well as incorporating some other sources of data that we pull in. We'll prepare it specifically for building a predictive model to predict that IMDb score, and then we'll show how that can be a repeatable process, and we can play around with that and sort of test our own movie pitches. And so with that, I'll actually jump into the software here, and we will go through and start within Vera Construct, which is, as Alex laid out, is our data preparation tool here. And so Vera Construct is what allows us to actually go through and prepare data for analyses, for predictive models, as well as just share the information, create a nice clean data set for other coworkers within our organization that may be doing the analysis themselves. So within Vera Construct, what we have here are jobs, and these are all of the data workflows. So those are the processes that we create to prepare data for some outcome. Down below there are all of our connections. And so as I mentioned, connections and data access is a huge priority for many organizations. And so through here, I can see all of the connections that I've established. As long as we have a provider to connect to that, we can really access any database that you're looking to work with. So you're pulling from Hadoop, you're pulling from Amazon Redshift, you're working off of Oracle databases, SQL databases, MySQL, you name it, we can connect to that location. And so in this case, for today's demonstration, what we'll actually be working with are some extract files. So we'll be pulling in the text file that we downloaded from Kaggle, and then we'll also look at incorporating some additional sources of information that we actually scraped from Wikipedia as well. And so the first thing I'll do here is just open up this brand new job. It's kind of starting from scratch. This is our job workspace here. And the first step in really any process is connecting to a data source, creating a connection, pulling in the data, and then from there we can actually start to learn about that information or that data that we have there. And so in this case, I have in a folder here this data set that I've downloaded, and I can just drag it over and just drop that right into the connection window, and we can just pull that right into the workspace. And so we've just connected to that movie metadata file. And then within here, I can go through and actually implement some of these different tasks to profile this information. So we could look at creating some reports off of this to visually and sort of automatically inspect these records. But for here, what may be a sort of a better demonstration is to actually look at the data set itself. And so we can go in and actually view data and take a look at the individual rows of data here and start to just get some perspective and learn a little bit about what exists in this table. And so this includes movies from many different years. I can see we have things like director name. We have the number of Facebook likes for the director and actors. I can see over in this genres column, we actually have multi-valued fields. So we have many different genres separated by a vertical bar there. So something that we may want to parse out. I can also see under movie title, we have some data entry errors, something probably from conversion or from download with the coding of the file, but we see double question marks in all of our movie titles, so something I may want to clean up. And so we can go through and start to get some information about this table here. We can also dig a little bit deeper if we want, and one thing just from kind of going through this previously is we can look for distinct values within columns, or I can just sort columns here, and I can see we have quite a few null values within our director name. And so if I look at these movie titles, I can see it's in fact what looks like some TV shows here. So we have MASH, we have Empire, so things that we may want to exclude if our analysis is really meant for predicting movie scores. And so just by quickly sort of going through this data set, we can start to identify certain problem areas, things that we're going to have to clean up before we actually get to the modeling stage. And one other thing that we can see here is we actually have some duplicate values, and we can start to identify those or sort of investigate those further, see if it's a remake or if it's in fact the exact same record, just duplicated. And so once we've kind of gone through and sort of done a little bit of viewing of the information, I can start to actually build out the process. So we have some ideas of things we want to do. We want to remove our TV shows from this data file. We want to clean up the movie title, remove those double question marks. We want to dedupe the records, and then from there probably create some additional variables that we can use within our model. And so starting out, the first step was probably filtering out those TV shows. And we could do this a number of different ways. Sort of the quickest way here, and probably not the best way in the long run, but is just to remove those records with a missing director, assuming that all of those are TV shows. And so I can bring in a filter here, and I can go right in and I can find that director name, and I can just remove that or say this is not missing. So we need some value within that column, and I can add that right to my filter. I could go through and actually individually remove movie titles, probably not ideal here. Another option would be to get a list of all TV shows, merge that together, and sort of remove those as well. But I think for now, for our purposes here, we'll go with this. But one of the nice things within Vera Construct here is that you can leave notes. So again, making this something that's not only reproducible, but something that where any user could go through and sort of understand at a glance what exactly is going on. So we could say we're removing TV shows. And in addition, I could leave a note here and say, may want to check for alternative method. So you can create notes along the way, sort of build out this process so that you have points to kind of go back and check on. But for now, this seems to be sufficient. And now the next step was looking at those movie titles and sort of cleaning up all of those data entry errors or those additional characters that we see within those columns. And so for that, I can actually use a cleanse node, and I can drop that in as well. And in this cleanse, I can go through and identify what column I want to cleanse, which was that movie title. I can go through and see all of the values there. And what I want to do is just replace all characters, all of those double question marks, with really nothing. So I essentially want to delete those from the text there. And so we can use, in this case, a substring replacement just to say when you see these double question marks, replace with nothing. And so we can add that in quickly. And again, being able to do this very intuitively and without having to write any code here. And so once we have that set, we can again save and exit. I can leave notes here as well. And then the next piece of sort of cleanup was actually removing those duplicates. So taking out duplicates based on movie title in this case as sort of our ID field. And so for that, we again have a node specifically for that where we can bring in a dedupe. We can connect that right on, and we can select any fields that we want here. So we could have a combination of fields. We can also choose a selection rule. So if there's a particular reason we want to keep one record over the other, maybe it has a higher IMDb score, we can choose that as well. And so once we have all of this implemented in the process here, I can just preview data. So if I wanted to sort of take a look at how well we've done up to this point, I can get a sample of records, and I can actually see the row counts here. So we started with over 5,000 records. We filtered out to about 4,900, and then in our dedupe, we removed about another 100 records of duplicates. And then I can go through and I can take a look at the actual data here. So I can see, does the movie title contain those question marks anymore? So we've gone through and done a nice job of cleaning those up. And so really at many different levels and any different stage, you can see sort of the progress that you're making within the data. And so beyond that, and sort of the maybe most enjoyable part of this process is thinking creatively about what information doesn't exist in this file that I can create. So are there different measures from some of the information that we have that we can include in this data set that may be predictive of the outcome we're looking to measure? And so I can go through and actually create new fields here as well. And for that, we can use a transform. We can drop that right on. And in this transform, there's a whole number of different ways to perform all of these different operations. And there's preloaded functions in here. There's quite a long list of them to go through and create different values. In this case, if we want to use sort of an easier route, we can go strictly to our text functions. And thinking back to that genres column that was multiple values separated by a delimiter of a pipe, I can then select that genres field. I can choose the associated transform here or function that I want to use, which in this case is a subfield, pulling a subset of text from that column, and just saying I want the first set of text separated by a vertical bar. And this would just be our genre. And we can create that, and we can continue to build those out if we like. So we can do this automatically here, just cloning these over, but in this case, we'll just create these two here to show that as an example. And so we could do this for many other columns. We have other information in here like the gross revenue and the budget. So we could look at profit. We could look at a number of different calculations, maybe the total cast, Facebook likes. But in this case here, we'll just leave it as this for now. And we'll again take a look at sort of what this output's going to look like. And so in this case, rather than previewing, if I wanted to write it to a test file just to kind of take a sample here, we can then view that data. I can see again all of this cleaned up information. And then we can go through and look at that genres field and see how we did sort of parsing that information. And so from here, I could again go on, create dummy variables for this. We can really invest a lot of time in sort of the feature engineering or the creation of all of these new columns. And so to save you from that, I've actually gone through and done a lot of that work already. So I have another job here that kind of starts or picks up from this point and implements a few other features. And then we'll take a look at how we can incorporate some other sources. So in this other job here, we have really the same workflow that we saw. So we're removing TV shows, we're removing those question marks, we're deduping the table. And then here we've gone through and actually added in a bunch of new columns. So that's our genre dummy variables. We have sort of mined the plot keywords for certain elements to create dummy variables for those as well. And we even have a file here that removes or lists all of the TV shows that we removed. So if we wanted to review that and sort of double check those 100 TV shows that we pulled out of the table, we can go through that as well. Now, additionally, there weren't a ton here that we're using Python, but if you are currently using any scripting language, that can be implemented in the process as well. So here is a Python script just to scrape some tables from Wikipedia. So pull in or sort of copy over the information from Academy Award lists. So for Best Actor, Best Actress, and Director. And so this actually generates extracts here for me that I can also incorporate into the process. And so here we could pull any of those scripts in, just paste it right into the workflow, and incorporate either my own work or coworkers' work, and combine that all in the same process. And so in this case, if we pull those files in, I can drag those in here as well, and I can merge all of that information together. So I can combine all of that data and go through and add that to our output here. But again, as probably you are well aware, rarely, especially if pulling data from the internet, you are going to find that it's in a nice clean format. So this data too required some data preparation and sort of the constant theme. So as we get more data, we're going to be needing to prepare it just like all of the other information that we have. And so in this case, again, rather than putting you through sort of watching that process here, I've gone through and actually cleaned up all of this information in a separate process. So pulled in all of those same tables, performed a number of functions that we previously saw, so cleansing the data, transforming it to create new variables, filtering it down, etc. And so now I have this sort of module or this separate job that goes through and actually does all of this work automatically. And so if this were something that I was going to be using over and over, maybe it's a quarterly sales analysis or some other process that you are constantly calling upon and generating reports off of, you can sort of create this automated data preparation process where now in the other job, all I have to do is just point to this process using what we refer to as a subroutine and say, now pull the data from that data preparation job and return it into this workflow. And so in here, all I have to do is just select that job, and we can go through and find that Oscars awarded job. I can save that here, and then I can connect it right in with the rest of my workflow. So I can merge that all together now. And so we've now pulled that information into our process, and for each individual movie, we can now identify how many cast Oscar winners there are in that cast and how many nominations among the cast as well. And maybe that's a good indicator of their overall IMDb score with that information included. And so to join these tables together, I can just join right on that movie title, just drag and drop to create the process or to create the join. And then additionally, you can right click here to actually see sort of what the join will be doing. So rather than remembering left join, right join, and again, making this something that's interpretable and intuitive to really any user of any background, we can see, let's take all of our records from sort of our main source and then the matching information from our Oscar nominations table. And then we can just select those columns that we want for output. And so we can save and exit here. And then again, we can just run this to a temp out, or we can actually create an output table here. And really, as Alex mentioned, sort of in that product layout as well, any data destination is really accessible here. So if you have permissions to write back to a database, you want to write to a SQL Server, an Oracle database, you want to write back to Amazon Redshift, any of those data destinations are accessible here. But in this case, we'll just maybe write this to our temp folder, and we'll say this is a test file. And we can now run that. So we've now gone through, prepared this data, incorporated additional data sources, made this something that we can run on a schedule. So assuming that typically most of the data you're working with is stored in a database, you could have these processes run on a scheduled basis so that it always creates this clean file every Monday at 8 a.m. or whatever time you need that data refreshed. And then this is at the point where we can then jump into building a predictive model and sort of visually exploring this information. So we've gone through quickly and just cleaned up a lot of that input data. Now if we want to find those key indicators of movie ratings, if we want to automatically build a model around that outcome, we can then load this file into Veera Predict, and that's where I'll head next. And so within Veera Predict, again, you can connect to really all of these different data sources that we previously saw, but typically all of those database tables need some preparation. So generally we're working with those files that we create within Vera Construct. And once that file is created, we can then load it right here in Veera Predict. And the first table or the first window that you come to is really just a profile of the data set. So what columns are included, what data types are available, What is the min and max values? Do things fall within the ranges we expect? How many missing values do we have within columns? And so really some good information about how well you've done preparing this data set. But what we're really interested in is how do these things relate to the outcome that we're looking to predict? And so if we want to visualize this information, I can go through and take a look at really any of these different measures. And so one thing that we may suspect is that duration of movie may play a role. And in fact, it does. And I can go through and actually add some more data points here. We can visualize that a little bit clearer. And what I can tell is that maybe my data preparation steps weren't exactly perfect. We're seeing some durations of or average of 57 minutes, so likely some TV shows still included here. And so again, you have the flexibility within the application to modify that, identify those outliers, and actually go through and say, let's remove those here for now, assuming that anything less than 75 is a TV show. And so we can add that filter in and sort of clean up the data right here as well. Additionally, we can look at things like that may be a little bit more fun here to see, are there particular actors that positively impact or maybe potentially negatively impact the IMDb score of any of these movies here. And so we can look and see where those actors fall, what sort of ratings or average ratings their movies receive. And we can show that as an overall average as well. So I can see here Matt Damon pretty well above, Harrison Ford as well. And then we have a few others, unfortunately, for Nick Cage there, showing a negative correlation to a movie's score there. And so one of the really nice things about this is that we can visually see that. We can make assumptions about statistical relevance and which fields may be impactful for our analysis, where we may have some problem areas within our organization if it was something specifically tied to that. But you also have the option just to quickly mine the data, have Veera Predict here tell you what is significant. And so if we check this option, it shows me in green here all of the statistically relevant actors. And it'll actually create new variables for us based on this information. So I don't have to go through and create a flag for whether or not Matt Damon's in a movie. Veera Predict will do that automatically and potentially include that in our model. I can also see in this list now, we only have related variables. So if we include 300 variables, 500 variables in our data set, it's going to narrow that list down to those that are most significant or that are statistically related based on your own preferences and options here. And so for the sake of time, there's a lot more that we can go through, but we can head right to model. And in the modeling tab, we can pick and choose fields that we want. But in this case, we can choose to just build automatically, allow Veera Predict to actually build the best model based on the data that we provided. And with that, you can see quickly runs through, identifies the best model for us, and then has a number of different sort of validations that we can use to identify how well this model is predicting. But if we look at this variable list here, we can see all of the fields that are included. So director Facebook likes is important. We see that Matt Damon actually came in, so it created that binary flag for us. And if Matt Damon's in a movie will be given a higher predicted score. And so again, there's a lot of information that we can go through, different ways to sort of validate how well this model is predicting. But one of the really nice features here at the bottom is the percentage model contribution. So we can see actually what's impacting our model the most, and title years may be something that I want to take out. But title years is predicting or carrying the most weight when predicting an overall movie rating. And so once we have this model, we can memorize this. We'll call this our movie. We'll say IMDb score model, and we can memorize that. And we can create multiple models here, but again, as we're getting close to our Q&A time, I'll just save this model. I'll save it right to my desktop. And then quickly, we'll just run through sort of scoring that information and sort of play around with some different movie pitches. And we can do all of that right here in Vera Predict, but we're actually going to go back to Vera Construct because we have all of our data preparation steps already included here. So I can just pull in those exact same sources, prepare data the exact same way. So being able to reproduce the work that we just did on our new or our sort of test data set, and then implement that scoring model directly. So I can pull in that process or kind of point back to the process to prepare our movie data. I can then import that scoring model and just pull that right in. And then within this transform here, I can actually go in and view the formula. I can see exactly what calculations are being used to predict the overall score, what fields are being implemented, et cetera. But once I have that, I can then just run this output here. I can then view the data and see now all of the movies that we have here, the predicted score. This first one maybe could have been predicted just on name alone, but you can see the predicted score here of a 5. And then we can see those that are predicted to be the top movies. So Schindler's List, The Wolf of Wall Street, all pretty nice, pretty good movies there. Fight Club. So we have quite a few here that are seemingly most likely very highly ranked, and ones that our model has identified as well. And so with this, we can output this really again to any data destination, but we can also sort of play around with this this information and do some more what-if analyses. And in this case, with this model, maybe pitch our own movie ideas and see what sort of impact that has, or what our likely reviews are, not taking into account at all my writing abilities. But in here, we can use that same model. We can run a report that actually prompts us for those potential values. So what's our movie called? How many likes does our lead actor have? What genre is it, et cetera? And we can run with those values and view our report here. And so with that information, a documentary called Triple Risk that has a fairly popular lead actor would be ranked fairly highly here. So documentaries generally are given a higher score. The duration gives a little bit higher score, et cetera. And then we can see actually our casting list. So who do we have here that we can pull from and ask to be in our documentary, which maybe doesn't make much sense in that case. So instead, if we wanted to create an action movie, we'll leave it as Triple Risk. That sounds good to me. We'll say it needs to be a fairly popular actor. We'll make it action, and we'll reduce the time to 90 minutes. I can then see how this movie will do in the box office, so dropping it pretty significantly there. And then again, I can go through and find those actors that sort of fit that profile. I know it's kind of a whirlwind tour of sort of data preparation and predictive modeling, but I hope you have a pretty good understanding of sort of what that process looks like, the tools that you're really looking to implement, and sort of the features that are going to be most useful to you. So looking at automation, being able to schedule those processes to run, being able to visually identify those key indicators, et cetera. And so with that, I think we'll turn it over to questions here.
John and Alex, thanks for that excellent presentation. We'll get started with today's Q&A session. Thank you to everybody in the audience for your participation. We've got a great many questions that have come in during the presentation, and we'll do our best to get through all of them in the remaining time. During the Q&A session, I'll leave up this screen with contact information for John and Alex if you'd like to contact them for a copy of the slide deck following today's webinar. Let's get started with the first question. What sort of sources do you connect to? And do you connect to cloud-based databases like Salesforce?
Yes, so this is John again. So many of those connections are built in. So Salesforce is one of those. So out of the box, you're able to connect to Salesforce, Amazon Redshift, and a few other cloud-based databases. And then as long as there's an API for those systems, we can connect to them and pretty much any other database as well. So yeah, there's really hasn't been a data source that we've been unable to work with.
Okay. All right, next question is, can Vera Construct handle real-time data?
So it can. So we saw today primarily working off of extracts. Generally, what our customers are working off of are real-time database connections. So as soon as you kick a process off, or as soon as a process is scheduled to run, that's going to be pulling in the most up-to-date information. So generating that data at that point in time. And those can be scheduled pretty much as frequently as you would like.
Okay, thanks, John. Next question that came in is, how does the system deal with missing data?
Yeah, and that's one that we could spend a lot of time on. So the system in Veera Predict automatically handles those, and there's a couple different variations to handle those. So when building a model, if it encounters a missing value, it will assume the mean of that value, or you can choose to exclude the record from the model itself. Within Vera Construct, and generally where you're sort of attempting at least to prepare all of the data and clean it up, there are many different ways to handle it. So you can replace with the variable mean, you can impute a mean, you can replace values with 0 or other entries depending on the situation. So a number of different ways to handle those.
Okay. The next question has to do with the cache node. So what exactly does the cache node in Vera Construct do?
Yeah, in most cases, it's not at all necessary. In my workflow, I had actually gone through and sort of split the process. And so at that point, if you want, you can place a cache node in there, which is really kind of a storage point. So it creates a temporary file or store of the data set at that point in time, so that if you are querying a database that maybe takes longer than you wish, you can create a temporary file locally that you can work off of from there.
Okay. The next question that came in is a pretty good one. What is the competency level required to be able to master your product? Not a PhD, I hope.
Definitely not. I do not have a PhD, so there are many different levels of or sort of backgrounds, I should say, of users. We have a pretty we're pretty proud of our support structure, in which we offer free training and support. So anytime a customer is looking for some sort of backing of their predictive model, or if they have questions of the models that they're building, we're there to sort of take a look with them and see how those are coming out. So if you've never built a model before, we have plenty of training materials that walk through that within our product, and just generally about building predictive models, and something that our analysts here also assist with as well.
All right. Thanks for that, Joe. I think we have time for one more question. Can I incorporate my own scripts into Veera?
Yes, definitely. So one thing I didn't mention, we saw the script node to incorporate a Python script. So that's something that you can paste directly in. You can also incorporate SQL queries directly as well. You can also use, specifically, we have an R script node that has some built-in scripts in there, like neural networks and ANOVA testing, things like that. But you can also incorporate your own custom. So really, regardless of what you're coding in, if it's PowerShell, Python, R, SQL, pretty much you name it, you can incorporate it right into the same workflow.
All right. Well, thank you, John. Great answers to some very good questions. And for those of you that asked questions that weren't answered today, we will be sending all of them to John, Alex, and the Rapid Insight team so they can follow up with you after today's webinar. I just have a few quick announcements. Please mark your calendars for May the 14th, 2019, and our next DSC webinar, Adding Optimization to Your Analytics Toolbox. Today's taping will be available for on-demand viewing later today and can be found on the homepage of Data Science Central in the Webinar tab located at the top of the page. Past webinars are also available on demand at datasciencecentral.com. If you haven't had the opportunity to view them, I encourage you to take a look. They provide very useful insight into a wide variety of topics of interest to our data science community. This brings today's webinar to a close. I'd like to thank our audience for their attendance and thoughtful questions, and a special thanks again to Rapid Insight for their sponsorship, as well as to our speakers today, John McMillan and Alex Herbert, for their insight into today's topic. My name is Stephanie Glenn, and I'm very pleased to have been your host for today's event. I look forward to seeing you all again on May the 14th, 2019. Have a great day.